Okay, shall we begin? Let's try, join again. Okay, so we have found two characteristic equations, okay, in terms of eta x and zeta xy. Okay, so let's begin with case number 1 for the hyperbolic. Okay, hyperbolic equations. Okay, where you can see delta greater than 0. Okay, here I'm using the because since we are using small ABC, I'm using the discriminant of delta. Okay, so you know b squared minus 4ac greater than 0 for the hyperbolic equations. Okay, also I told you, I already explained you, in this case we will have a is equal to c is equal to 0, then only it is true. Okay, now consider the coefficient of u zeta zeta in equation number 8. Okay, so in equation number 8 only we have a something plus b something. Okay, u zeta zeta, this will be u zeta neta plus c u neta neta is equal to 0. This is our equation number 8, isn't it? So in this case, if you put a is equal to 0, okay, so what will happen? So actually what is a? Small a is equal to what? So we have derived from equation number 1 to 8. No? So there we have something u zeta zeta. Then the big one we take as small a. So what is that big one? Actually, a is equal to sigma x square plus b is equal to sigma x, zeta x zeta y plus zeta y whole square is equal to, if it is a is equal to 0, whatever this one is equal to 0, no? Am I right? So we have the equation 7. From the equations, I can write here. Since equation 7. Go and check the equation number 7. So you will understand that. So this big things only we have taken as a small e. Okay. So since if you wanted to satisfy this condition, I need to have that term as a 0. Okay. Then let's say I'm going to divide these entire terms with respect to zeta y square. Okay, I'll use another color. So see whether if you divide this equation, let's say this equation as small 1 something. So small 1 divided by sigma y square is what? Okay, you will have something sigma x over sigma y square. Okay, plus b. So sigma y cancel out. So you will have sigma x and another sigma y here. So sigma y. So sorry, this zeta. Okay, again c, this will be 0. Okay, am I right? I'm dividing this zeta y whole square of this equation. So it will be come like this. You can check your answers. Okay. Okay. Shall I continue? Okay. So keep this equation. So from the in the proof, we have found what is dy over dx. We have taken as minus sigma x over sigma y. Again, dy over dx also have neta x over neta y. Okay. So we can substitute that one here. That means a for the zeta x over zeta y, I can transform dy over dx whole square. I think negative no by b. So sigma zeta x over zeta y, I can put negative dy over dx. Okay. Again, plus c is equal to 0. Okay. So what do you think? This one is like a, for example, let's say I'm going to take A alpha squared plus B alpha plus C is equal to 0 kind of equation of quadratic equation. I can treat as a alpha is equal to dy over dx. Okay, like we have derived from there to a simpler quadratic equation. So what is alpha actually? Minus b squared minus 4ac, plus or minus square root of delta, no, delta. I'll write here delta. Okay, give me a second. I can write this one as delta or b square minus 4ac over 2e. Okay. So since we have plus or minus, we'll have two solutions. We called as delta 1, lambda 1, lambda 2. Lambda 1 can be, it's b, no, sorry, minus b. No? So it can be like, okay, what you'll get actually, sorry, give me a second. So did you get this one? I'm just putting for dy over dx as alpha. So alpha square b alpha plus c. Okay. So in terms of in this quadratic equation, what is alpha actually? Minus b, no? So here you see we had plus minus b. Okay, so here we have a minus, don't forget. So if I wanted to write plus, I need to take the minus as a bracket. Okay, so minus, actually in our answer we have minus b. So I need to put whatever here we got now. So according to the question, it will change. That's what I'm meaning. So I don't know you understood. Actually, if it is, for example, ax squared plus bx plus c is equal to 0, we have the delta is equal to, bx equal to minus b plus or minus square root of b squared minus 4ac over 2a. Okay, what if you get here minus 6 or minus something? Okay, so then this will be plus, no? This will be okay. Minus b whole thing squared will be b squared. Or the other term will be okay. So that's what I mean. Here it will be plus b. Okay, plus or minus square root of again b squared. Okay, minus 4ac. O A capital, okay, AC divided by 2 capital A. So I will have two solutions for this this equations. That will be like, let's take as a lambda 1, lambda 2. That is lambda 1 can be plus b plus square root of b square minus 4ac over 2a. Okay, or lambda 2 can be b again minus square root of b square minus 4ac over 2a. Okay, so we will have two solutions in this hyperbolic case. Okay, so this we will take as this one as a zeta, this one as a neta. Okay, so what we are doing is, okay, we are finding the zeta neta as a constant for this, the equations. Okay, so let me wait for that. Just put this one, lambda 1, lambda 2. So there are two different solutions, isn't it? So both are real, but different solutions. So these are the characteristic of this. Okay. Shall I continue? So if you have in the quadratic equation also, in this algebraic case also, if you have like this, okay, there are two real roots, isn't it? So we may study it in our school levels. So this have the two real roots. Okay. Okay. So let me continue. So what it that says is that is if delta greater than 0 of original PDE number 2, equation number 2, then we have two real roots of lambda 1 comma lambda 2. Okay. So that is so what is actually our lambda 1 will be dy over dx, and that's what we are solving. So alpha is what? Alpha is equal to dy over dx. So I will have two characteristic equation as, let's write like this. Lambda 1 x comma y is equal to 0, one of the equation. If you write the next characteristic equation, lambda 2 x comma y is equal to 0. We will have two roots. Okay. Then theta, let's take theta is lambda 1 x comma y and theta as lambda 2 x comma y. So one solution we are taking as a zeta and one solution we are taking as a neta. So that's what I told you. According to the type, the theta and eta choices will be changed. Okay. In this choice, we are taking theta as our first roots and the neta as the second root. Okay. Real characteristic. Real characteristics. Let me continue. So then, actually, what is our small b square minus 4ac? So from the, second, in the note, I have derived this one now. So it will be like b square minus 4ac Jacobian square. Okay. Actually, what is Jacobian? Theta x, theta y, neta x, neta y. Okay. So what is Jacobian squared will be this into this. Can you find the answer? So zeta x, zeta y, yeah, zeta y here, neta x, neta y here, zeta x again, zeta y, neta x, neta y. So zeta x, neta y minus neta x, zeta y, okay, times. So actually this is this one, and this will be transformed. So I think zeta x come here, neta x come here. So see whether you are getting this one. Okay. So I don't have the time. So I'm taking this one as see whether you are getting this one. Okay. Neta y minus neta x zeta y whole thing square. Okay. So this equation, do you remember this equation? They are also in the note also you put like this. So you can write that way. Okay. As a star. Okay. So from this, since in the hyperbolic case, we have found A and C are 0. Only B may is greater than 0. Then the equation 8, we have, okay. So in the case of equation number 8, we have something like that. No? U, X, zeta, zeta, plus B, U, theta, neta, plus C, U, neta, neta is equal to 0. Okay. What if it is this one 0? Okay, this is 0. This is also 0. So I will end up here only, no? So what is this? Also b greater than 0. So for example, I have this one. Theta neta is equal to 0. So b also greater than 0. So I don't need to consider this one. So the final answer will be this. So we have proved, okay? So since, yeah, this side we have something like this, no? You can't put 0, no? It will be chi, okay? So u zeta neta is equal to chi. Chi depend on zeta, neta, u zeta, u neta. Okay, so hope I have derived this answer. Okay, this is how actually things. From the theorem, okay, if you take zeta and neta as a constants, okay, you will derive our main hyperbolic equation. If this condition satisfied, you will have the canonical form as u zeta neta is equal to 5. So that's what I have derived. Okay. So similarly, we can okay, you can write here as this is the canonical form of the hyperbolic equation. Okay, so in this equation number 8, take another color. Okay, so what happened is this equation number 8, I put a and c 0, so this and this are 0. So only I have this one. So this is equal to 5. So this is my final canonical form for the hyperbolic equations. So for this, I have derived so many things. So hope you have understood fully and write down. Okay. So if you are late, please take the screenshot also. Okay. So see here. So we have get our small delta, and then from this we just used our equation number 8 and do some modification. Then we have found our characteristic equation. Then there we have solved our equation. We found two roots. Okay, on that roots we have used two characteristic equations. Also, this lambda one, first root we are taking as a zeta, second root as a neta for our hyperbolic case. Okay, and then for this case, we are reducing, if you are using a and c is equal to 0, you can get our final answer will be for the hyperbolic case, u zeta neta is equal to chi. It's our final canonical form. Okay. So go through again and understand again. Okay. So let me make it faster for the parabolic and elliptic. So we can do some, I think we have 15 minutes. Okay. So I will give as a homework for you. Okay. So if time permits, I can do in the next lecture, but I don't know. We are reaching our end of the semester, so I need to finish quickly. So you better work with something. Okay. I'll give you the idea. So please work yourself. You can find everything in the, everywhere in the books, so in net or anything. Okay. So only thing is you have to find out whether what will happen like that case number 2, parabolic equation. I already gave you the idea. In this case, we will have a and b 0. Okay. So only thing is you have to derive from this. Okay. You have to derive our parabolic equation of canonical form, this one. Okay, child. Okay, can you try yourself? Make a space, and this is your homework. So you can try this case number 2 for the parabolic equation case. Same way. Okay, so in this case, as you can see from our algebraic knowledge, so if you have delta is equal to 0, you will have the same root. X and x are same roots. Okay, repeating roots. Okay, so that's the only thing you have to keep in mind. Okay. And in that case, we will have only one lambda, okay, dy or dx. plus lambda is equal to 0 is our characteristic equation. Okay. So what you have to do is you have to choose zeta is equal to zeta is equal to zeta is equal to zeta x comma y, but neta we don't have the equation. Okay, so that's the only problem here. Okay, there you can have any independent choice according to the example questions. You have to choose the neta yourself. Okay, so we will I hope to do some examples, then you will understand. Okay, in here, since we have only one root, the root you can take as a zeta or neta, anything. Okay, but the other variable you have to choose yourself. It's an independent choice. Okay, but it has some conditions to satisfy. Okay, we can see that in our example. Okay, let me finish up this theorem proof. This is also your homework, case number 3. Okay, in the case number 3, it is the elliptic case, delta less than 0. Also, I told you here b can be 0 and a can be, a can be, sorry, c is equal to a or a is equal to c. Okay, so you will end up the canonical form u zeta zeta plus u neta neta, which is equal to pi. So see whether you are writing here. The only thing is here, if you get delta less than 0, you will have a complex root. Okay, so there is a small steps there. Okay, complex root. So you can refer your some books or anything or internet things. Okay, so try to gather this answer. Okay, so I would like to, I have 50 minutes, so I can do some examples, so you will understand more than this. Now I'll choose one question from one type. So, and I hope to get some questions for your homework quiz. So I will send later. For now, I'll start on some of the examples. Okay. So these, please leave some spaces for these homework things to fill up. Okay, now let's begin some examples. Okay. So according to the examples, it may differ, but what you have to do is, first of all, you have to find the type, then you can use the ways what we have done for from the theorem, then you can derive. Okay, for example, the questions can come, transform, write down the question, transform the following equations into canonical form. Okay, this is how the question may arrive. So so I'll give you the question first of all. U x minus x squared u y which is equal to 0. Let's say second question. 4u x plus 12u xy plus 9u yy 2ux plus u is equal to 0. So I like this question. Again, third one. Everything is second order. We choose e to the power 2x u xx. So this is how the question will arrive you to solve. Okay. Plus y u xy plus e to the power 2y u yy, which is equal to 0. Fourth one can be u xx plus 2 xy plus 17 uyy, which is equal to 0. If case, let's say x squared uxx plus y squared uyy, which is equal to 0. So please write down quickly and take a screenshot if you want, and continue the thing. I will start to solve one questions possibly, so you will get some idea to solve the other. Okay. Now, let me continue. Have you finished writing? So you better take screenshots also, so you can write later. Okay, let me start to do the first one. Okay, first of all, the question is 2x. Just copy the question first. Okay, in the exam words. Then we know our actual general equation a uxx plus b uxy plus c uyy plus something. Then pi is equal to 0. Okay. So you have to know whatever the uxx terms as a capital E. Okay. So here, what do you think? What is the A? First of all, your thing is you have to find what is A, what is B, what is C. So this equation, since this is dependent on x and y now, so this is our original equation, this equation. Okay. So here, can you find out what is A, B, C? So you can see uxx, axx. So there's one. Okay. So I don't have a time, so I'm just, I'll try myself. Okay, b is equal to, there is no uxy terms now. So there you have to take 0. And whatever c is equal to, this is a plus. So you have to take whatever negative comes. Okay. All right. Then delta. What is our delta? According to the delta only, our types comes. First of all, you have to find which type is it is. Okay. So b square minus 4ac. So which is equal to 0 minus 4 times 1 times. First of all, you write nicely like this. If you take plus or minus any mistake, it will be ruin all your, all the answers will be changed. So you better carefully analyze it. Okay. So this will be negative, negative, positive 4x squared. What do you think? 4 is greater than 0. X squared always greater than 0. So totally this will be greater than 0. So in case of delta greater than 0, we have, therefore, it is a hyperbolic equation. Okay, so we have found our type. So this is our first step. Yeah, they are asking you to check the canonical form now. We just only find the hyperbolic term. Okay. Then, so next one, you have to write the characteristic equation. So as I said you, in the hyperbolic case, our characteristic equations, consider dy over dx. So you have to, if you can memorize, you can memorize. Otherwise, you have to know how it's derived. Okay. So as I said to you, dy over dx is our characteristic equation of this one. Okay. So now substitute b is equal to 0. Okay, plus or minus. This one we got the greater than 0 now. Something 4x squared. So I don't want to do again. I'm just using the answer, early answer. 2 times and what is that? 1 percent. So 2 plus or minus, square root of this will be plus or minus 2x divided by 2. So 2 cancel out. So I will have plus or minus x. So don't forget about the plus or minus. Okay, it is. If it, only things you have to keep in mind, if it is hyperbolic case, you will have two solutions. So you have to be careful on plus or minus. Okay. So I will have my lambda 1 dy over dx equal to x equal to 0, one of the case, and another one dy over dx minus y is minus x equal to 0. These are my characteristic equations. Okay. Now, okay, so let's continue. Yeah, let me continue in the next window. So what if dy over d, okay, my meeting also going to finish, so no problem. So dy over dx plus x equal to 0, okay. So dy plus x dx, I'm just cross producting this side, okay. Integrate this one. If you integrate, okay, this will be y. This is a total derivative, no? So according to that, it will take, okay, y. This will be x squared by 2 which is equal to C1. Okay. And also I have another one, dy over dx minus x equal to 0. So I wanted to show you the idea. So I'm just doing myself. You just copy and understand. Okay. So if you again integrate, you will get y minus x squared by 2 is equal to another C2. Okay. So what is our actually theorem is our theta and eta are constants, isn't it? So I'm taking this was as my theta, this as my eta. Okay. So actually my zeta will be y plus x squared by 2 and eta is y minus x squared 2. So far we have done the things to find out our theta and eta choices. Okay. So according to the example, according to the question, the theta and eta will be changed. Okay. So we only thing is whatever you find this way, the C1 as a constant only we are taking as theta, other constant we are taking as an eta. Okay. So you better use the plus 1 as a theta, minus 1 eta. Okay. Don't, confuse yourself to plus and minus here and there. Okay. Please follow the rules. So then only you'll get the same answers. Otherwise it will be, somewhere it will be missed out. Okay. We have 5 minutes, so I need to finish. Please make it fast. At least I need to do one question, so you can proceed to do the all other questions. Okay. Okay, from these zetas, what you do is find the zeta x, find zeta y, again find zeta xx, find zeta x, yy. Okay, also in here, find neta x, neta y, neta xx, neta yy. Okay, so you know how to do that now. You just do the partial derivative of this. Okay, that's yours. I'm just gonna show you the way. Okay. So leave a space and come with me so you can fill up later. Then what you do is consider our u is a function of u zeta x comma y and neta x comma y. So this is how we have transform. Okay, you can write like this. And then after this, what you do is you find ux. Okay, so it is a chain rule. We already found this one in our general case. Okay, see whether what is ux is uyy. Why I am only considering this one is in our what is our example? I mean uxx minus x squared uyy is equal to 0. This is my question now. So I don't need to find the xy, what is other terms. I don't need to waste my time to find the uxy. Okay, this is enough. Whatever the question comes, you find this one and this one. That's enough. Okay, so you may have something like u zeta x plus u neta x. Okay, then you take the second derivative and from this find the uy and then find the uyy. Okay, so these things are already there. You go and copy or you just do it again. Okay, then what you do is whatever you find here and here. Okay, let's say this is my equation number 1, 2. Okay, so you just substitute. Let's say this is my equation. Substitute this 1, 2 in our start equation. Okay, so whatever 1 minus x squared, whatever our 2, which is equal to 0 now. Am I right? Yeah, then you simplify. Okay, when you simplify, see whether you get this one. 4x squared u theta neta minus u neta plus u theta is equal to 0. Okay, this is my second equation. Also, I have found what is my theta, what is my neta. Okay, so substitute this. Okay, after you find theta and neta, so we have some x squared now. See, this one in zeta neta, this one in zeta, this one in neta, sorry, neta is zeta. Only things we don't know is x square. Okay, how you can find the x squared is, see here, our theta is, what is our theta? Y plus x squared by 2. Okay, neta is y minus x squared by 2. So if you want to take the x squared, you can subtract this one. For example, theta minus neta is what? Y and y cancel out. So x squared by 2 minus into minus x squared by 2. So totally it will be x squared. Okay, check whether this one correct. Then you can substitute for this one. For example, let's take, okay, let me finish up. That's all. Okay, so our answer will be like this: 4 theta minus neta times u theta neta minus u neta plus u theta is equal to 0. Okay, so you can say actually our hyperbolic equation is I told you zeta neta is equal to psi or something, no? So see here, zeta neta, if you take only zeta neta, if you take these things in this side, you will have u neta minus u zeta divided by 4 zeta minus theta, because this is like a pi. Something depend on zeta, neta, u zeta, something like that. So which is equal to pi. Okay, zeta, neta, u zeta, u neta. It's depend on that. Okay, so this is my final answer. So you have to give like this final answer, whichever in this format. Okay, so after that you have to rearrange it and give this answer. So that's the answer. Okay, so please see that again and find how I have solved, and take a screenshot if you want this one, and try to solve the second, third, and up to fifth one as possibly. Okay, so if I have time only, I will discuss. Otherwise, it's your studying things. Okay, so you have to try yourself. But anyhow, if I got time, I will explain the this. I have explained you the hyperbolic case. If possible, I'll try to so parabolic at one and one elliptic. Okay, so let's finish up our lecture. Okay, good luck. Take a screenshot if you want. I'm gonna close it. Okay, bye.